Hello, everyone. Today I will tell you how to build your own IPSec ike2 server with MikroTik Router OS. This presentation will show you how easily you can run your own ike2 VPN for protected remote access. This presentation should be interesting for beginners and advanced MikroTik users. So first case, if you are already using another VPN with MikroTik, like OpenVPN, PPTP, and you are looking for something better. Another case, you already tried ike2 but failed. This is my third MOM presentation. First one was in Moscow in 2017, covered 1,700 visitors. Second one was in Vietnam 5 months ago, covered only 40 visitors. No trainers there, but I'm going to teach them soon. My presentation became big while building, but much informative. So I'll do my best to hurry up. By the way, please let me know if my speech is unclear, fast, and so on. So let's start and have some fun. So a few words about me, your speaker. I come from Russia, Moscow. I have been traveling around Asia already for more than 1 year, a real digital nomad. Engineering while traveling. I love kite surfing, and because of that, most of the time I live in Vietnam. This summer I'm going to spend on Bali. MikroTik network engineering is my primary business. Because of my deep MikroTik knowledge, my office is traveling with me inside my backpack. Yeah, actually I just came from Phuket. VPN and remote access always allows me to travel around Asia while earning money from rich guys who need stable, high performance and hacker-proof network infrastructure. I took MikroTik courses in Moscow in 2016 and got 5 certificates. Also, I'm listed in official MikroTik consultant in Russia on the mikrotik.com website in consultant section. In 2017, I launched my own freelance outsourcing business, MikroTik PRO, in Russia, but right now I'm slowly making my business offer worldwide, especially in Asia. I'm now working exclusively with MikroTik only. So let's say Router OS language is my second language after Russian, and even better than my English. Here are my contacts. Sorry, I didn't list my phone number because I keep changing my SIM cards and IP addresses because of traveling. WhatsApp is also connected to SIM card and constantly changing. But I'm always online for you. Feel free to contact me through listed contact details. Being online 24/7, 365 is my business. So next slide. So please grab my small V card just in case. And we continue. Okay, go. Okay. Why ike2? This compare VPN types. I did it by my own. So I tried different VPNs. From OpenVPN is the most simple, but the slowest one. Yeah, it's strong. I like it. There are two biggest problems with OpenVPN. First one is it consumes a lot of CPU without hardware encryption. Another one is it's using TCP in MikroTik. Yeah, and it's slow because of that. And also doesn't balance multi-core, no balancing. So Here are 7 advantages of ike2 against all others. So yeah, blazing fast throughput performance, instant connection establishment, really 1 second, sometimes less, depends on your ping. Military-grade security standards, IPSec. Supported by most modern operating systems, can also push routes. For example, L2TP IPSec cannot push. Bypasses any NAT. Mobile friendly, what does it mean? It means that, for example, with your mobile phone, you have connection established and you switch from Wi-Fi to 4G and back, your connections will not lost. It keeps tracking connection. That's why I call it mobile friendly. So let's start with network diagram for our setup. Okay, start with simple things. That's how I explain newbies. Yeah, that's how newbies understand how internet works. That's how advanced users think internet works. That's how network IT juniors think internet works. That's how we think internet works. Okay, I will simplify a little bit because I promised to make this presentation simple and clear. That's why, yeah, it can be like that. But we go to a simple setup to be clear and easy. That's our setup. This what we're gonna build this thing. It can be like that. Also, I was thinking to make presentation to show how to do that, but no, I will not fit in my time. So that's why we can discuss it later. If you ask me any questions, if you want to do like that, but we will do this one. Okay, starting with configuring router S. First. Yes, that's our agenda. So yeah, warnings. Before you start, I would recommend to have MTCNA knowledge. My presentation will be about router S 644 because maybe you noticed after 643 MikroTik has lots of changes in IPSec, especially in ike2. I would strongly recommend not to do this lab and pro practice on your working environment or on your production environment. First, please check on your any small box or virtual machine. So my presentation will be really step by step. You unpack your MikroTik small router, Hub Mini, any, and do step by step, and you get the result. So start with don't try to implement in working. Really, I don't want to get your emails, hey, my business is done. Yeah, I would also recommend, I will rely on the default configuration of MikroTik of these small boxes like home boxes, because the default firewall, I will also explain based on the default firewall to simplify understanding. Yes, and as I already said, starting from 643, MikroTik did lots of changes in IPSec, so we will cover it. So first, yeah, I need to upgrade. I don't want to explain it. It's just, first you need to upgrade your machine. Reset to default configuration. Yeah, you see I did the full on a map light, the smallest MikroTik router. So even on this machine you can launch ike2 VPN server. So all my tests did on this MIPS PE, the smallest one MikroTik router. Okay, let's go. Let's go for general system settings. You need to set up one IP address with a public DNS address for your VPN router. You must set time zone and NTP. I will show you. So yeah, it's assuming our configuration, that's default configuration, brand new router. We have IP address, public IP address 123.45.67.8. This IP address will accept IPSec connection. And we have a DNS that's globally resolved, because this DNS will be connected to certificates that we will generate later. So you have domain name, you have IP address. The domain name resolved to IP address. Set up correct time zone. That's very important. And set up NTP, because certificates and encryption relies on correct date, time, and time zone. Yeah, time zone doesn't matter. It's just for you to read logs. But correct date and time is very important. So NTP client should be running. So next step, we add a loopback bridge. And assign IP address for this bridge. So we add a new pool for VPN clients. So these VPN clients will use IP addresses from this pool. Okay, next step is generate certificates. We need to generate at least 4 certificates. If you already have your own certificate authority, you can skip this step. But let's assume you're working with a lab, with a brand new router, taking out from box. So these steps are important. So here, first of all, we need to generate certificate authority. So then we can sign our client's certificate and our server certificate. So these all fields are very important. Then we sign this certificate, self-sign. Then we generate a server certificate. Very important to put subject alternative name here, because clients will check for this field if they compare the real DNS server where they connect with this alternative name and the common name, both. Some clients, they check alternative. Some clients, primarily, they check common name. So I would recommend to take care of this field. Yeah, so you select days, how many days you want your certificate will be valid to reissue it later. Yes, so then after that we sign the certificate with our security authority certificate that we built before in the previous step. Next one, we generate a client certificate template. Then we use this template to copy and launch as more client certificate as we want for our clients. So this important thing, TLS client in key usage should be set. And the subject alternative name, email, should be email for proper generation, for proper usage, for best practices. So after that, we generate a new certificate. You can do it by copying the here. Okay, sorry. Uh-oh. No. Uh-oh. Wait. Okay, this template, next one. We generate a new one, common name, set up any email address. I set up this. After that, we sign the certificate. So we can do as many certificates for clients as we want. So C1 is, as an example, each connected client should have its own certificate. It's not like a pre-shared key, then you have one shared key for everyone. Any new customer should have, client should have its own certificate. And I would say that ike2 doesn't allow to make two simultaneous connections with the same certificate with my setup. I will explain it later. So after that, after you sign your certificate, you do your export. So very important, do you export in PKSC12, and export passphrase should be set. Otherwise, your private key will not be exported. If you don't set up the passphrase, you will only get the certificate without the private key. Then you export the security authority. For some clients, you need to specify separately security authority, for example, in iOS. So type PM, don't set password, export, you will have the certificate authority certificate without exporting the key. Never export certificate authority certificates together with keys. So don't set password. Okay, then you will have these two certificates after exporting. So we can already, everything is done. We are ready to start setting up IPSec. This agenda for this stage. So maybe who already tried to set up ike2 or IPSec before can notice that there are two new things, two new blocks appeared in IPSec configuration, peer profiles and identities. Identities makes really magic in 644. I will explain later. Okay, let's go. So first we go IPSec and start with making modeconf. What is modeconf? Is the section where you can define IP address or a pool of IP addresses where MikroTik, where the client takes IP addresses from. So let's say MikroTik promotes this IP address to the connected client. So we normally set up address prefix length 32, then it will make true peer-to-peer connection. About split include is the cool feature of IPSec. Here you can define what kind of routes you are going to promote to your clients. For example, 000/0 means default gateway. So client will take this to, it will use your MikroTik as a default gateway and send all traffic via your IPSec ike2 connection. That's very important. Then you also can promote your DNS servers, so connected client can use DNS. Next step is IPSec proposal. I don't want to deep dive into IPSec technology, but this is about phase 2. Okay, I'll try to explain very simple. This is set of encryption algorithms used for encrypting data between client and server. There are 2 phases in IPSec. First phase is about establishing connection, encryption on the stage of establishing connection. Second stage is encrypting transfer data. So IPSec proposal is about phase 2. How are we going to encrypt each packet of transaction of all transfer? So this is the best practice recommended for most operating system, especially very important thing about lifetime and PFS. PFS non-reducing security. I don't want to explain why. So much complicated. I promise to make it simple. But PFS group none will make compatible, especially for iPhones and some devices, improve compatibility. So if you switch PFS on, choose any of algorithm, then you will have problems with iPhone connections at least. Lifetime 8 hours is recommended by MikroTik Wiki for road barriers. Okay, another thing I would recommend to disable MD5 because it's outdated hashing algorithm, and disable D3DES and enable all IS encryption algorithms here. This I tested different combinations. This is the best practice I found after long tests with different devices. For let's say Android can connect, iPhone not, Windows connect, old Windows 7 cannot connect with, and blah blah blah. 3DS, Windows 7 likes 3DS, but it's outdated one, not so much strong. So, okay, this is best practice, use it, and then you can Google more after your success. Next step is about phase 1. IPSec profile. Here you define algorithms. Here you define encryption algorithm for phase 1. Phase 1 is about establishing connection and generating keys for encryption for phase 2. So this is best practice, how I normally recommend to set you up. If you don't know what is it, just copy like that. Here is the code. And proposal check is, I would recommend you to set up a bay for maximum compatibility. It's about how your client device, iPhone, MacBook, or Windows, or whatever, checks for proposal matching. So obey means your phone will, MikroTik will take promoted by end user device. Kind of slave. NAT traversal is very important for ike2. I'm not sure if this box makes any sense for ike2, but for ike1 for sure. I didn't check yet, but always keep this on. NAT traversal makes your connection bypass nets. For example, you have 3 clients connected through one router, one NAT router to the same MikroTik server. Okay, here you must define a IPSec policy group. Just no settings here. You will use it later. And after that, go policy templates. So here, a little bit magic. On the source address, you define zeros because this connection is a template. It's complicated to explain here. I think I would better show you what to do because explaining this, how policies works, can take so much time, and it's not a goal of my presentation. My goal is to show you how easy you can launch a VPN server. So, destination address, you just simply put all IP addresses from your pool of VPN clients. So all traffic coming from clients to any will meet the template, will meet this policy profile. Group, you select the group from the previous stage. We built this group. Make it here. Template is very important because we never know from which IP address client connects. So MikroTik templating, IPSec templating is a kind of technology that takes the IP address of connected clients to generate IPSec policy. Action encrypt. IPSec protocols ESP. SA source and SA destination leave zeros. And proposal check that we made for phase 2 on the previous stages. So here we make peers. Peer is an endpoint that accepts IPSec connections. So address is IP address from which endpoints we accept connection. So 0000 means we accept connection from all the world. This IPSec is open, taking connection from any IP address. Local address, here we can not specify if you have, for example, more than one IP address on the interface or you want to accept connection on any IP address, you can leave this field blank. But in my case, I set up exact IP address where I want to listen for incoming connections. The profile. Profile is the profile from phase 1. We selected from the list. We already built it in the previous stage. It's a profile for stage 1 IPSec, phase 1. And very important thing here, passive means MikroTik is not trying to establish connections with an IP address. It's only accepting. And exchange mode ike2. So this is the thing that came in 644 only. It's the earliest feature. the latest feature, I think, and the most fresh one. This thing is very, I think, looks complicated, yeah? So here we need to assemble all bricks that we made in all previous steps. Okay, here is we made upon previous step. For each customer, for each connected client, we make a different IPSec identity. This is from my best practice. You can go in a different way. I don't want to explain all different cases. For my case, for example, I have 10 customers. I want each customer to dedicate him a separate certificate. That's why I go this way. So peer is the API, the peer where I accept the IP address. You can. So hard to explain. Auth method RSA signature means you authorize by certificates. So here, the next step is certificate and remote certificate. That's a very important thing. Certificate is a server certificate you selected from the list. We already generated before. And remote certificate is the certificate for exact client you want and to authenticate. Policy template group is the group for policy template group is the group where we want our client to assign the dynamically generated template policy, policy from template. We have, our case is very simple, so MikroTik allows you to assign different policy template groups to different IPSec identity. It adds you lots of flexibility, but together with complexity. Our case is very simple, so that's why I will explain you. We have only one policy template group. We will push all, put all our clients to this single policy template group. Okay. Next step is important. Also, remote ID type. Use user fully qualified domain name. So it's about the email we used in our certificate when we generated them. And match by certificate. And then mode configuration. We have only one mode config. As we made it, it's where our IP addresses, pools, routes, and there. For different clients, it's a very important case. If you have, for example, 10 clients, and you want to separate them into different IP address pools, you can select, you can make different mode configurations for Office 1, for Office 2, for Office 3, and select which mode configuration and which IP addresses, which routes you want to push to exactly this client. I would say these IPSec identities, there were no options to make more than one identity. There was only one single identity. That's why the previous versions of ike2, 643 and earlier, were not so much flexible. So these new identities makes magic. Okay, I think a little bit complicated. Yeah, another thing is aware for guys who is watching this presentation in the future, for example, YouTube viewers. MikroTik announced changes in 645, so they renamed digit RSA signature. You see auth method RSA signature, and they rename it to digital signature. That's very important. So if you're working with 644, use this script, the previous one, this script. 645 and later use this one. Okay, let's go to next step, setting up firewall. Default firewall I want to explain. Lots of guys have MTCNA here. Should I? How many guys have MTCNA? Can you? I want to understand. Should I deep dive into firewall traffic control? Because lots of problems caused with IPSec because you don't understand how traffic control works, how firewall works. You already set up a brilliant IPSec configuration by manuals, but there is no explanation how to set up firewall, NAT, and so on. So people have lots of issues simply with firewalling, and they cannot establish connection. Okay, sometimes you establish connection, but you cannot ping what you want. And no traffic. I will a little bit deep dive into setting up properly firewall and understanding what are you doing. So this is the default configuration. I think everybody knows that. It's the default configuration for home routers. This is the code. This is how default firewall looks like. So where is forward chain, where is output chain, where is input? So router has, you see, 1, 2, 3, 4, 5, 6 directions for traffic. 2 forward, 2 output, 2 input at least. This is traffic coming from LAN. This is traffic coming to LAN. This traffic goes, understanding chains. I want to explain how chains looks like. So this is the traffic output chains coming from router S. This input chains to router looks like that. And these chains coming from 1. And these chains coming to 1. Okay, so this is back to default firewall. That's how it looks like. Short summary. MikroTik will accept all input packets for established connections. MikroTik will accept all input ICMP packets. And MikroTik will drop all input packets except LAN. So to be clear, that's how it looks like. It will decline all input traffic except ICMP. From LAN, it also allows you. Also from WAN, you have 2 exceptions. ICMP, as I already mentioned, and also all packets that marked as DSTNet. So from WAN to LAN, only packets with DSTNet will be allowed. So that's how it looks like totally with all exceptions. So that's very important to understand before you start setting up IPsec firewall, how your router handles incoming and outgoing and forward connections. So that's how empty firewall looks like. Important thing. Team? That's how empty firewall looks like. You think some guys accept firewall rules and leave everything empty. I see lots of firewalls with only accepting traffic rules. It means that your router will not stop any connection. No traffic. So next step, after I explain how firewall looks like, we need to add some extra exceptions to allow IPsec traffic incoming, just to establish connections. So for now, all incoming traffic from internet is blocked and only allowed all traffic coming from LAN. This is from default configuration. So your VPN clients disconnected, while they cannot connect because it's all blocked. Only IPsec only ICMP is allowed by default. So what we need to do is to make 3 rules to allow IPsec incoming connections. So here we add 2 UDP rules is using by IPsec. UDP 500 is to establish initial connection, I think for phase 1. And UDP 4500 is for NAT traversal, and ike2 uses this one for NAT traversal because ESP cannot bypass NAT. That's why they use an UDP encapsulation to bypass NAT. And the same thing we do with IPsec ESP traffic. Doesn't have any ports, it's just type of, this is protocol. So we allow, and I specify destination address because I don't want, I want only incoming connections to this IP, but you can make it wider, this filter. Doesn't matter, but this is for my security practice. So and put these rules before you drop this for default configuration. So what you will have after that? You allow your clients connect to your router. So VPN clients can establish connections from the world. But you will, after you allow this, your connection, your client can establish connection and it will have VPN connected, but you will have no data, no traffic there. I didn't mention there are 2 magic rules in new configurations. I will explain later. There are 2 magic rules with IPsec in and IPsec out that are in new default configurations are on. I think I can find it. I think I can find it here. Yes, number 5 and number 6. By default, these 2 rules, I will explain a little bit later, but by default, these 2 rules allow any IPsec encrypted traffic incoming and outgoing and forwarding the router. Yes, here. So okay, on this stage we're only allowed to connect to the router, but actually, yeah, you can stop here. Already everything will work, but it's not a good security practice. So that's why I would like to explain you how to set up VPN traffic rules manually. Back to our packet flow diagram. Your clients are connected. There's nothing new here. I add only connected clients to our router with the subnet. Okay, a little bit hardcore. I promise you to explain what does it mean. So you see, all packets with this firewall rule, all packets encrypted with IPSec in and IPSec out will not be filtered by firewall. So what does it mean forward now? We have three networks now. One, LAN, and our VPN pool of customers. So we have much more forwards now passing through the router. So it means that IPSec in and out will allow, this default rule is lazy rule, allows you all traffic to bypass router in any direction. I would recommend you to disable it and go to manual configuration. So what we want to allow input traffic from our clients. For example, we want our clients to use our MikroTik as a DNS, as NTP server. So any services that can provide MikroTik to your clients, we should accept it. So this is the comment: allow all incoming traffic from our VPN subnet to this router OS. So the next slide will be about forward traffic. So let's say we want our client to access our LAN. So we make this firewall rule. So we don't use any interface, we just only using IP address pools. So from source address, our ike2 clients, and destination address is our LAN subnet. And very important thing here is policy in IPSec. So it means that MikroTik will check if the traffic bypassing is from IPSec connected clients. And also we want to allow traffic from VPN clients to the internet. So it's a forward chain also. And we allow it with the same rule. And yeah, destination address any. It's not a good security practice, but it's simple. So if you want your, so let's say the big difference here, here we only allow to access only our LAN network, but not internet. Uh-oh, wait. And here we allow without limitations from VPN to internet. So instead of 000, you can specify any IP address subnet, or you can put not sign, and then so up to you. Depends on what you want. So setting up NAT. Problems with a NAT. Guys who don't understand how NAT works, I will try to a little bit to explain you. So let's say you have a laptop and there is no NAT, and your laptop has 88.94 IP address, and it tried to ping Google, and Google doesn't know nothing about your IP address, or your private IP address, so your internet will not work. Your pings, you try to understand it. What's going on? Is maybe firewall problem? No, it's NAT problem. Your ping is not working because you don't set up NAT properly. So what NAT does, actually, it replaces the private IP address with the public IP address. So after that, Google knows where to send back replies. So what about IPSec? This is from I think I don't want to deep dive into encapsulation because you know there is a problem. You can break your IPSec with the wrong NAT setup. So very important thing, you must source NAT your encrypted traffic, that is unencrypted before it goes out to the internet. So first you source NAT the packet, and then it encrypts and goes to the internet. This is from default configuration. That's how default configuration looks like. Before that rule, there were lots of problems with the customers. I think support of MikroTik has many problems because lots of guys, they break IPSec because they source NAT IPSec traffic after encryption. So what we normally do here is source NAT VPN traffic to 1 from IP addresses to 1. We need to source NAT. That's how it should look like. I would say that this, by default, it will work out of box because this rule is already here. It will not break your IPSec. So this is copy-paste. It will work. I would recommend you also to use source NAT instead of masquerade. So in the previous step I showed you're using masquerade on all WAN interfaces. But best practices is to use source NAT. If you know exact interface, for example, you have dual WAN, Ether 1, Ether 2, LTE, you do source NAT for all outgoing interface with the IP addresses which you know provided by your ISP. with static IPs. Yeah, and put it up before the default rule. Okay, I'll try a little bit explain about TCP, MSS. I know lots of guys have problems with IPSec because of misunderstanding what is TCP, MSS. I think I have enough time. I'll try to hurry up. So let's say we have a VPN interface somewhere. We want from our laptop to reach the website. On the way, we have somewhere VPN interface that with MTU lower than both of interface on our ends, somewhere lower. So what happens here? If the traffic reaches this way, the packet size will be 1,500 bytes all the way. But what will happen if traffic is passing PPPoE? It will break packet into fragments. So your laptop will send a big packet according to its default MTU. But as soon as it reaches the router where there is a PPP, any VPN tunnel, it will break packets. It will split because the big packet will not fit inside this tunnel. So the router will split it into 2 or more. So that's how it happens. So let's say starting from 1,500, passing into Ethernet, then after PPoE it breaks into 2 packets, then Ethernet, no filter here. So all packets coming here, and after that you will have IPsec tunnel with MTU 1,400. So at the end you will have 3 packets. And if any of this not packets, packet fragments, because it's all small packet fragments or with orange and red colors. So here very important to understand where performance decrease. If one of these packets breaks, is not delivered, of these fragments is not delivered, then your full packet will be retransmitted once again. That decreases your performance so much. So I was trying to explain it. I drew it by my own. I didn't copy it from internet. I will try to explain it as simple as it possible here. Very important thing. So with IPsec, by default, you have on most of Ethernet, you have by default 1,500 bytes, 20 bytes taken by IP, and the all data of IP packet is 1492. What happens with after the packet is encrypted by IPsec engine? You have here 1,400 bytes is a payload. All the IPsec will replace with internal mode is very important here. IPsec works in 2 different modes. I don't want to go here. For tunnel mode, it will look like that. It will replace your original IP address. And after that, add some ESPs, encryption keys, related stuff here, and auth is integrity check here. I don't want to deep dive here. Very important thing here is 1,400 bytes. You have a packet can fit inside the. So new encapsulated packet can only fit in 1,400 after all IPsec stuff. After all IPsec. I forgot the word. So after all encryptions, you can only carry 1,400 bytes. Yeah, this compare of ESP packet and with the NAT traversal, because NAT traversal adds a UDP header also, but all contains in 1,400 bytes, both of them. It's best practice. So okay, now we're working only with this packet. Our packet is now not 1,500, 1,400 only. What is it? TCP segment is the payload of TCP packet. The maximum size of TCP segment here is already 1,360. The payload, the HTTP data, or I don't know, 40 bytes already taken by IP and TCP header. So yeah, this next slide explains everything. So inside TCP, it's all your layer 5 payload. It's always MTU minus 40 bytes. Okay, try to explain a little bit going back to TCP MSS. That's my simplified explanation. You can make picture if you want, because it's not. Let's say your browser wants to establish TCP connection with a web server. He says, I can transfer you 1,460 maximum segment size, and the web server replies, I also, because it takes from Ethernet, it takes MTU. Your browser takes the MTU of the interface that is going to transmit data through and calculates TCP maximum segment size. Server does the same. Both they have Ethernet connection, 1,500 MTU, so they can both transfer maximum TCP segment 1,460. But between them, there is a small IPSec tunnel that doesn't allow you to go faster than 1,400. These guys both don't know. This is why fragmentation happens always. Because these both guys, they don't know. But how to reduce it, how to avoid this fragment. Yeah, if the router will split packet into fragments and deliver from your browser, from the router, so packets will come in one, split into two different parts, and go to the web server. And the web server normally will assemble packets back. So how, and it will keep on going. How to reduce the maximum, how to avoid fragmentation here is to reduce TCP scene. TCP scene is a TCP flag. Browser can TCP clients can negotiate maximum segment size using TCP flag. So with MikroTik, you can intercept this TCP flag and reduce it. So your browser is sending. Next slide. That's what you can do with MikroTik router to help them to negotiate the proper maximum segment size. Your browser sends 1,500. MikroTik intercepts this packet and transfers already reduced one, both way, from router to web server, from web server to router. So the trick is MikroTik can intercept and work as kind of a man in the middle to intercept the TCP connections. And then it will, so this browser with web server, they will now talk with maximum segment size 1360, and there will never happen any fragmentation with a TCP. Actually, there are PathM2 discovery protocols available, but in some cases where routers filter ICMP, your PathM2 discovery will not work. So this is a very good idea to help to let MikroTik help to both sides to negotiate the proper TCP connection, maximum segment size of TCP connection. So, and actually that's how it looks like. The IPSec packet is still 1,500 bytes. But inside IPSec, it will fit, the payload will be 1,400. And you should notice here that you should only reduce, never make it higher than it is. So, okay, let's come back to Winbox. Looks complicated, yeah? All packets coming from source address with protocol TCP, with IPsec in policy, with a TCP maximum segment size higher than 1,361. All SYN packets reduce MSS to this one. Don't try, if it looks complicated, don't try to analyze it. Just copy paste and it will work. Both directions. It was from browser, from our clients, source address. And this two, both directions of TCP session negotiation. Okay, I would say that MSS, you should use this MSS only if you issue any problems with MTU on your interfaces. I have for you a demo lab. So, I will launch my demo lab after this MUM a little bit later. I was much more focused on the presentation. Demo lab. So first, so who wants to see how it works? I have this demo lab already working online to connect and to play with settings in read-only mode. Okay, you can just analyze to see how it works and copy configuration in the cloud, in Google Cloud. So, 4 steps you need to do to access this demo lab with the working IPsec VPN server. Request the certificate via form. I will issue your personal certificate for you. Then you can connect this router. I will send you by email. Connect to VPN server and access via Winbox. So here, I made a special Google form for you. If you want, you fill the form, and I will send you maybe tomorrow. Today, I think tomorrow, after tomorrow, in a few days, I will send you back email with your certificate that you can use to connect to the ike2 server and see how it works. And we can discuss if you have any questions later. I can help you with your setup. Yes, I will send, as I already explained, I will send you a little bit later. ike2 VPN address server, I will send you with email. I don't want to publish it here because it's worldwide. YouTube viewers also see that. And yeah, access via Winbox. As soon as you connect it, you will get the IP address, so then you can connect to this lab, use a login lab, password lab. This is the private IP address of VPN. Okay, next step, I think I don't have already, I'm already taking 1 hour. I can try to do fast forward here. Windows 10, macOS, iOS, Android. I have lots of slides, but I will try to show it fast. Windows 10, you can download this presentation later with all these screens. You don't need to remember that. I will just show you how simple is that. Windows 10, first you download certificate. Then you import it to local machine. Yeah, certificate that we already downloaded from Winbox for exact customers. C1 at you already remember. You can download it from Winbox. I'll send it to you by email. So local machine, next, the file is already selected. Enter the password. You remember we made a secret password when we did export for the certificate with a private key. Automatic. Next, import successful. You go here, set up new VPN connection. Here, there's simple things. Everybody knows that who use Windows 10. Yes. Internet address VPN ike2, destination name according to our certificate. Go to the properties, need to adjust a little bit settings. Here you select type of VPN ike2. And use machine certificates. MikroTik will find the proper certificate and use it for authentication. Don't ask me questions if you have more than one certificate. I still don't have answers for this question. I'm working with that. Okay. Establish connection. Oh shit. Oh, sorry. No. Oh, good. It's Windows. So here we connected. You see IP address is already got. The very important thing that differs VPN, L2TP, and different other protocols. As I already told, ike2 doesn't have a gateway. I don't want to explain why. It's hard to understand, hard to explain, but here it is. Connected IP address, no gateway. Let's check what we have for routing. It's using its own IP address. We got IP 10.0.8.8.2, and it's using as a default gateway with a metric 26. So here, what about, I already mentioned that ike2 can do route pushing via split include. So here how it works. So for example, we want only to provide access for our connected clients to our private networks. These 3 networks we have. After connecting, we have all these 3 networks in our list. It will use MikroTik, Windows will go to this network via ike2. But there is an important thing. The default gate, even with this configuration, you see still MikroTik has Windows uses this ike2 connection as a default gateway. How to fix that? Okay, for our case is we just only provide, we want to provide our clients, our customers, our office users to access to our local office network and not to bypass all the traffic via office router. So they use their internet by default via their default gateway in an internet cafe or wherever at home, but only for our local network. Traffic will go through the ike2 connection. So we want to disable that. I mean, not to allow MikroTik or Windows to go through ike2 to pass all traffic. So we go back to settings, networking, properties. Here, go to advanced settings. And uncheck the box, use default gateway for remote network. Okay, fast Apple, similar thing. We have another certificate for Apple. We go here, enter the password that we already used. You remember that since last time? So you will have here 2 certificates. In Windows, everything was made by default. In Apple, you need to adjust some settings. So by default, Apple will not trust certificate authority certificate that you imported with this file. So we need to change some trust settings. We open this certificate. You see CA. Open this certificate. You see certificate red. Certificate is not trusted. So we want to fix that. So we need to verify that the fingerprints are matching. This is the correct certificate. CA. All good. Matching. Continue. It's about security. You can skip that if you're brave enough to import security authority without checking. Come on. Oh, sleepy. Okay. So here, I would strongly recommend to never trust everything else, only IPSec. Otherwise, you can have security issues if something happens with your CA certificate. Yeah, here type the password for the system, go, okay. Go to the networking, system preferences, networking, add VPN connection, unlock first, create a new certificate connection. So here, local ID, I would recommend you to put it here. Normally, Apple will and MikroTik will take this local ID from certificate subject name, but I normally use this. It's better to do that. So, yeah, don't forget to put show VPN status in the menu bar. It's a good trick. Then you can connect from the top bar, status bar. Oh, there. Okay, then go authentication settings, and authentication settings use no and use machine certificate. Select. Use your client certificate. Continue. All good. We connected. Okay, Windows already check routes. Oh yeah, here you can connect from top bar menu. Very easy and see status. This is routes. So how this, you can see we already have pushed static routes, and the MikroTik will only, MacOS will only go to our private network without accessing internet. It will use its own gateway. Okay, next step is, if you want to allow all traffic going to internet to use ike2 as a default gateway, you use split include zeros, and all traffic will go to internet, not only to our local network. iOS, that's very simple. You save certificates. You can download it from your email, from WhatsApp, from messengers, from internet, whatever. You can deliver certificates. Dropbox, whatever. Let's click on the certificate authority. Download it first. Install CA. So download the profile. Verify fingerprint. I don't want to comment here. You see everything. Very simple. Install the certificate after all warnings and enter the passcode for your iPhone. Yeah, here do exactly the same with the client certificate. Download it, go set profile, download it, install, enter the certificate password. On this step, you must provide a certificate password that we generated in a Winbox for this exact certificate. And here, you add a new VPN configuration, general VPN add configuration, type exactly as it here, user certification no, use certificate, and select the certificate that we already downloaded on the previous stage and installed, I mean. And local ID, I would recommend to put it here. Same. Description, up to you. Remote ID is very important because iOS will verify remote ID with the IPSec certificate name. So then you just simply connect it and we got our IP address. That's it. Okay, fast with Android. Android still doesn't support IPSec ike2. This is a very big disadvantage. That's why I put it in the end of the list. So first we install third-party app StrongSwan. It will use only, can utilize only via StrongSwan. Import SSL certificates and then set up connection. StrongSwan client look like this. Install. Thank you, Andre, for screenshots. Download certificates. Certificate name. You name the certificate. After that, put server name, your VPN server host name. Select certificate from the list you already installed before. And then profile name. And CA certificate will pick up automatically. Because P12 certificate, that one that we already downloaded. No, I don't see it here. Already contains a CA certificate. So yeah, set it up like that. Connection type, ike2 certificate. After that, connected. Yes. That's it. Just in case If you want to play with it and you have any issues, connect. Send me email. I will help everyone. For the certificate request. Who not did the screenshot? I will send you. Yeah. That's all. Thank you for listening. Thank you for watching. Sorry for complicated things. If you have any questions. Questions?